Say we've got Joe here. Joe is an expert in PoE lighting and automation, and he is super excited to talk to you about designing a PoE lighting and automation system, taking a PoE lighting and automation system and converting it to PoE.
Okay.
So with that, you don't want to hear from me, you want to hear from Joe, but I will continue to stay online, monitor the chats, let me know if we're having audio issues, and I'm excited to see what you have for us today, Joe.
All right. Well, thank you all for the time. I appreciate. Happy to take any questions in the chat box afterwards. My goal here is really kind of to give you some insight if you've got a PoE lighting design from the reflected ceiling plan, how do you turn that into an actual design that rolls out into physical products and ultimately an implementation. So how do you design a PoE using a layout, starting with a layout? So let's start with tools required. So 4 things essentially you're going to need. The first and probably the most important is some kind of CAD software like Bluebeam is my preferred CAD tool of choice. You could use AutoCAD. You're going to need Microsoft Excel or Google Sheets, some form of calculating software, and then a large monitor and a scroll button mouse. So just a quick example. Let's talk about the components in the system. So most PoE lighting and or PoE systems have essentially 3 components. The network switch, which is pretty common, and then one layer below that is a gateway. This gateway kind of acts as an air traffic controller. So it manages a bunch of IoT devices. Ours is specifically a Linux server. I'm a strong believer in Linux and its stability. It is PoE powered. Underneath of that, we have a node or a driver. So this is what actually drives the LED fixtures, for example. But this gateway can connect to other devices such as sensors, wall switches, all of that. We talked about the network switch earlier. So this is an example of a DC powered network switch that we have that would connect up to a power supply. This is an example of a 3,000 watt redundant power supply. How does it all network together? We got a network switch, the gateway, and then all of the IoT devices. The beautiful thing about PoE is that it's standards based and it's a highly scalable architecture, so you can add as many of these as you want for all intents and purposes. And then you can plug in new technology as it comes. So lighting is just one of the things that we support. We also support shades, cameras, and a bunch of other devices. But let's talk about lighting. So specifically, you will need a lighting fixture schedule. So having gone through this process many, many times, you or anybody else who has lighting fixture schedules change all the time. So they'll start out potentially with what an architect has. They'll often get iterated and updated with what lighting reps will include, add, or change. If it goes through a VE, value engineering process, you'll see this update and change. I highly recommend that you have this in an Excel spreadsheet that you can update very quickly. You will need the spec sheets for each of the fixtures. So are they capable of supporting PoE? What are their power requirements? How many do you need? Is it a constant voltage or a constant current fixture? So often like tape light will be constant voltage. A trough overhead will be a constant current. You need the reflected ceiling plan. And then what is the control's intention? What do you want to have controlled by a specific wall switch or an aux sensor? Which group of lights are part of this room? And then what are the local energy requirements? Are you in California and you have California Title 24, or do you have ASHRAE standard you need to comply with, or is it just user preference? So let's take a look at the lighting fixture schedule. So essentially we have set up from the fixture schedule that we had talked about earlier, this table essentially of a type A, type B, type C, its corresponding size. I believe in having all the counts generated automatically, but you can fill in the power of each of those fixtures. So when we do a power budget later on, this number is essentially incorporated in through all of the formulas. We're essentially going to create an Excel spreadsheet with 3 tabs on it. The first one is going to be our fixture schedule. The second will be essentially our outputs, what fixtures and maybe GFI receptacles. And the third will be our inputs, sensors, wall switches. So once we have the fixture schedule created, want to take a look at the spec sheets for the fixtures. You want to make sure that these fixtures can support PoE. So some of these are buried deep down in the fine print. Others are a little bit more explicit, but you want to make sure that these fixtures are supportable in a Power over Ethernet system. There are two types of fixtures. You're going to find a constant current, and that's essentially where the driver is just pushing a steady current through the fixture. And then there's a constant voltage. This might be a 12 volt or 24 volt. Often you'll see tape lights or cove lights that are a fixed voltage. So those are the things you want to keep track of. When we look at the reflected ceiling plan, we're going to bring that into, like in my case, I use a Bluebeam review. And what that allows you to do is pull in the PDF, and then you can overlay that with these symbols. So I've created a symbol library. If you would like a copy of ours, I'm happy to share it with you. But essentially, you're going to create 2 to 3 copies of this reflected ceiling plan. As I mentioned earlier, the first one is going to be our devices, fixtures, and plug load. Second is going to be essentially our drivers, our links in our case. And then in the third is an inputs, where we're going to connect sensors and or wall switches. So in this case, you can see I've essentially drawn fixtures over top that essentially account for our 2x2s, 2x4s. We have some downlights here, and then back here we have a few wall sconces. So these are the type A, type B. This is a 2x2. This is a 2x2. This is an example of a 2x4. All of this will essentially roll up into your OT or occupation technology drawing set. So that includes architectural diagrams, the division of scope, IoT device locations, and then the OT network. Once we have that, essentially we're now going to do what I consider one of the most important things, which is a name. Everything needs a name, because every one of these is individually addressable. There's nothing more personal than a name. And it's really, really important that that name is meaningful and significant. So my typical recommendation is, so you can see I have a room number here, and I often will find in the drawings a room number. If there isn't one, I would recommend adding one. But what I recommend is you typically have the room number underscore the output wire that it's attached to. So if I have a node and this is attached to output wire 1, this one is attached to output wire 2, then I would have the room number underscore 1 or underscore 1, 2 if it's a color tunable fixture, and then underscore the MAC address. So this is, I've got a node that's controlling these 2 fixtures. I want to know what the MAC address of that is. Each one of these nodes controls up to either 4 fixtures or 72 watts. Maybe 90 if you're closer to the switch, but just for conservative, I usually say 72 watts. So, third copy of this is the sensors. So I took this and showing you on one sheet. Essentially, I've got this procedure room. I've got a wall switch here. Again, I used a similar naming lexicon. This is wall switch 108, and it's connected to inputs 1 and 2. This is aux sensor 108. This one is a wireless sensor, so it doesn't have the same wiring or naming schema as the others. Once I have all of these in my bill of materials, and I've gone through and I've created all of the fixtures and the controls and the wall switches and the aux sensors, I'm going to essentially, what I say, be the bomb and become the legend, or more realistically, get the bomb and make the legend. So I essentially am able to get all of the components for each sheet, but then I'm also able to get the bill of materials for the entire project. And that essentially I'm going to now export into a CSV file. So you can see here I've created an export function that generates this CSV file. From the CSV file, I can filter all of the nodes. One of the things this helps me do is identify and make sure I've got unique names. It also, based on alphabetical sorting, I can identify where each of my fixtures is relative to the others. I take that list and I essentially now go back to my Excel spreadsheet. We talked earlier about creating this Excel spreadsheet. Let's talk about just say the outputs, the fixtures that I'm controlling. Essentially, I'm going to start with this exported data and I'm going to put it in this column. This essentially is going to look at my controls intent, and I want to know what group is this fixture a member of. So if I'm in the waiting room, this fixture is going to be part of a waiting room group. Or if it's part of room 105, it's going to be part of group 105. And then all of this data I'm going to pull in automatically from my schedule, my fixture schedule tab that I made it earlier. And you can see I'm using a lot of formulas. I'm happy to share these. But essentially, these are all going to be lookup tables in my Excel spreadsheets. So we have the MAC address for each of these devices, these nodes, what they're controlling. I'm going to essentially start looking at my load calculations. So attached to each of these nodes, I want to make sure I don't go over a budget, say 80 watts, or obviously 4 outputs. So from this, I've essentially created 2 intermediary columns that essentially are all of my base names and node names. And so I can then uniqueify that list. And then from that, I get a total list of total number of nodes that I need. And then essentially I can then go calculate what is the total load seen by that node. So in this instance, I've got 20 watts on F100A. This F100I, I've got 80 watts. I can look at the total sum of power for my entire system and see I've got 0.38 kilowatts on my emergency and 2.69 kilowatts on my total system. So that tells me what size power supply I need, and then ultimately for my emergency system, what size batteries I will need. And then I got the total fixture count, and the EM count. So essentially with this spreadsheet, and why I've done it in the spreadsheet is I can go back, I can change the layout, I can change the fixture schedule, and this all gets rolled up very cleanly, and I don't have to go through and individually change any of the line items. I literally just paste it into this column, and then everything else just updates automatically. So now we're going to do the same thing for the inputs. Again, we're going to export it, and you can use a lot of the filtering capabilities that Excel has and offers, and go pop that into your spreadsheet. And then essentially now I've got the tables and the corresponding installs. This ultimately drills down to the as-builts. So working with the installer, you now have a full recipe of how this thing was created. And then using a lot of the intelligence in Power over Ethernet systems, it will confirm back, it will read the system and tell you, it will generate an as-built, and you can confirm with the intentions of the installer. Okay, so I got a couple of FAQs. I strongly encourage you to put more questions in the chat line, and Tyler will pop them over to me. But I'm just trying to grab some of the common ones. First one, plug load. So I know, for example, California Title 24, you have to be able to control plug load with occupancy and vacancy. In this paradigm, really, plug load is just an on-off fixture. You have a control element that's controlling that plug, you're going to associate it with an occupancy group, and that occupancy group will turn on or turn off that plug load based on that state. Code compliance. So one of the beautiful things about our system and many PoE systems is that everything is software capable. So for example, let me give you an auto off, auto on can have a trigger of an occupancy sensor going occupied. It can turn on the lights, or we can ignore that and now require the manual on of the wall switch to control the lights. So using software and using all of the capabilities of a PoE system, we have the ability to do auto off, manual on, auto off, partial on, or auto on, auto off, auto on. Emergency lighting. We have lots of one-line diagrams as a reference, but essentially we have 2 network stacks, one that's emergency backed, one that is utility backed, and we have the ability to essentially make sure that the lights come on when you lose utility power. Dynamic color tunable temperature, CCT. So we have the ability in PoE systems by attaching not 1 but 2 outputs, one controlling the warm string, one controlling the cool string. We can dynamically adjust and adapt the color temperature of that fixture. And so back here, for example, in this room, this whole room is a CCT downlight controlled room, so you can adjust the ambiance however you want for whatever time of day you want. One of the other questions is, well, I still have a bunch of high voltage fixtures and pendants. We actually have PoE controlled phase dimmers and 0 to 10 relays. So no problem. We can just incorporate it, and when you're ready to replace it with a regular PoE or low voltage fixture, we can replace that single instance, and it doesn't change any of your software. How do I retrofit to PoE? That's a wonderful question. Send us an email. We have some unique and interesting technology that will support 2-wire retrofits over existing Romex wires. All right.
Fantastic, Joe. Excellent presentation. Hey, y'all. I'm going to bring us both back up here so you can see both of our handsome faces, although we know who's got the better one.
Nope.
If you have some questions, we got about 5 more minutes now that we had planned for the live stream. Throw them in the chat line. Ask the questions. Let us know what you would like to know. Now, in case you're worried and you're like, geez, Joe moves fast, that's a lot of information. We will post Joe's presentation on our Bixie website at PoEtexas.com. You can hit our trade show or booth at Bixie, and it'll take you right there.
Yep.
So you can see it. We'll post his presentation. We will also post this video so you can go back and ask questions. And finally, Joe will be manning our Bixie booth for the next half hour or so after the presentation, so you can talk to him directly if you would like. Now, if you're just joining us and you're like, hey, I'm not in Bixie, I haven't joined Bixie, I put in the chat line a link so that you can visit our Bixie booth for free, which is the right price right now. You
can't go wrong with that price.
Can't get wrong with that one. So, Joe, I just want to reconfirm in the last few minutes while people are putting in their questions, the main tools you're using is a CAD software.
Correct.
Or Bluebeam, and that CAD and Bluebeam allows you to do the drawing markups and put the devices where you want.
Yep.
Now, a big question a lot of people would ask is, do you need to put a device, a PoE device, we showed our link, at each light fixture?
Good question. No. So one of the advantages of our PoE Link device is that it actually supports 4 outputs. So we can have up to 4 fixtures attached to each of these Link devices. So for example, those downlights that you saw, we can attach 4 of those per link. So the cost of that essentially is divide by 4. So that only requires 1 Cat6 cable, and it has 4 18-gauge wires out to each fixture. And if you have a wall switch or other inputs, we can connect that directly as well.
Yes. And then we were talking the other day, so that covers the light fixtures. You can do up to 4 light fixtures, 1 node device.
Yep.
And I know that's true of other manufacturers. Like we also distribute Igor, and they have either 2 or 4 devices. Another question for you then is, what about the gateway? So I'm going to flip back here. You were showing this gateway.
Yep.
How many gateways should I be planning for a space? And we call it a core tap. But how many gateways do you need in a space, and where do you put them?
So one of the things that I like is for this gateway to kind of map to the human geography. By that, I mean, I think it makes most sense to have a gateway per suite or per floor or per building if it's small enough. There's no technical limit to the number of drivers or devices you can attach to this gateway, but just from a human perspective, I like to see 1 of these per floor or per suite. These are not that expensive, and ultimately our architecture supports as many as you want, and they have the ability to communicate with each other. So if you want to have groups or scenes or inputs shared between them, we have the ability to support that. So I typically recommend 1:20 ratio, but we've done 1:300 easily.
And that's 1:20.
One gateway per 20 or up to 300 nodes. We can have. There's no technical limit. It's more just a logistics. Because if you have 5,000 of these things that it's connecting, then that becomes a little bit unwieldy from a interface perspective.
Mm-hmm. And then I saw that you had talked about grouping, and I think that's an important feature to kind of really highlight. As you're looking at the design, you really should be looking for logical groupings.
Yes.
And then planning to implement them and actually, in the way you would put it, in your naming convention.
Yes.
So that way groupings aren't just a virtual tagged item, which you can create in the software. That's totally normal. But the naming convention helps lead organically to that. And I think that's an important statement.
Yes. So it's really important to look at the human elements for all of this. So I'm going to erase some of these. I'm going to highlight. So for example, I have these two fixtures as one group, but I may have a group that's much larger than that. And the beautiful thing about software is you can just create a group of groups. I can have a group of groups, and I can have an entire group for the entire thing. So the groups are really where you get to the human element of what is this space. The human should not be worried about what are the physical pieces that are controlling my lights or my sensors or any of the other elements in building automation. So this group is an abstraction of the physical to what you know and understand about the space.
And Joe, this is another question I have for you that I'll be curious to get your input on symbols. If you're doing the drawings and creating the symbols, is there a convention or tool you use for your symbol creation right now?
I have some of my own, but I try to leverage as many low voltage and high voltage engineering symbols. So for example, a dollar sign is commonly used as a switch. But if you have a multi-button switch, like a 4-button switch, we tend to get a little bit more sophisticated and look a little bit more like a 4-button switch or a 2-button switch. But a simple, dollar sign can be a symbol with a number at the bottom telling you how many buttons. So symbols are flexible. We have our way, but many people have their own library.
And then one of the things I'll reiterate again, I really like the fact that you do an Excel spreadsheet of the fixtures, because Excel spreadsheets nowadays import so well into CAD drawings. And the goal here is that you're not recreating, like if you go in and manually create the table on the drawing, any changes, you have to go back and update it. Very often now, a good CAD system will just link to a spreadsheet, and you track your items on that spreadsheet, so that way as you're making as-builts, as you're correcting problems that may come up through RFIs or change orders, you're not having to manually update. Because frankly, doing the drawings is going to be one of the most expensive, time-wise parts of a PoE project that you can do.
And anybody who's been through the construction process, often it is bid at the 80% level, so it's never actually 100%. And so the installer often has to figure out that last 20%. But then once you actually get into it, as-builts are never as intended. So there's always circumstances, there's always events that come up. So having an automated system that can essentially track changes and make sure that the integrity of intention is brought all the way through to the final deliverable to the owner.
Fantastic. Hey, Joe, you've been a great host. Thank you very much for your presentation, and thank you for joining us today. If you would like, in a couple hours, Joe and I are going to come back on, and we're going to put pencils down and actually show you how to wire and configure a PoE space. So we have light fixtures, we actually have devices, we're going to actually wire them up. You're going to see Joe and I wearing our, you might capture us wearing some knot ties and suits. But that's really important, because this is just element 1. Element 2 is actually understanding the physical aspects of wiring and installing a system. So come back this afternoon, watch that. We will post Joe's tools and post Joe's presentation to the website, so you can go back and watch it, as well as capture this video on YouTube at any time. So we'd like to thank you so very much for coming. We will see you this afternoon. Enjoy your time at Bixie. Catch Joe at the booth anytime, and we will see you in a little bit.
Okay, we're out.
they'll still hear us. So if we say everything, they know we're talking.
We're still on open mic.
Oh yeah, we're on open mic. We never shut down the mics here at PoE, Texas.
Great. Yeah, how many political blunders have been on open mic?